lecture know about saying pressure sensor is this in almost every smartphone. So do you know that your smartphone has pressure sensor, micro pressure sensor? Huh? Why your smartphone need a micro pressure sensor? Why? Any idea? Why pressure sensor, micro pressure sensor was used in our previous what kind of application we mentioned in our previous lecture? Huh? One student, Chi Yan, said touch screen. No. We mentioned in our previous, why? In previous lecture, what kind of how will you press sensor? Like 30 or 40 years ago. How? I hope you still remember. You say you attend the lecture, but if you don't study, then I don't think we mentioned touch screen for the pressure sensor application. The first thing we in our previous lecture, what do we mention? Huh? Well, we're going to have this kind of midterm exam. I do hope we describe this kind of several times, so that if you just listen, don't study, careful to understand, then you may have problem. No, it's not blood pressure sensor. One of very, very mature application for pressure sensor is not for biomedical, it's not for smartphone. What's the application? Huh? Well, I do hope you understand. One of the most mature we mentioned in our previous slide, this lecture note. What I hope you. Any student still remember? In a car. No, it's not airbag. It's oh good. Finally, we have one student for engine. The one of more very, very mature this kind of pressure sensor in the I would say probably at least 30 years is for pressure sensor for the engine control. This is something we mentioned. Okay, we have one student. Yu Tao finally provide a good this answer, so correct answers, right? So that remember we discussed this one, and I do hope you understand why. So that again, so this is something we just if you just don't carefully study, then so that then you forgot. You say we do mention about this one in our previous lecture. No, I was surprised you. Most of you cannot answer this kind of very simple question. Huh? Let me quickly go here. We do mention this one. You see, pressure sensor, I do show all this thing for this engine. I surprised that some of you cannot answer this kind of simple question. Because why engine needs 1%? Because engine, what engine? Engine basically is we have to use mix this kind of air with this kind of oil, right? Gasoline, and then by right mixing of this kind of air, oil, right? Air fuel mixing, so that optimize this kind of a ratio, so and get best kind of combustion process. So this is something. Let me just try to describe again, so that this kind of pressure sensor is used to control this kind of mixing of air and this kind of gasoline, the oil, fuel, especially oil, why in engine, car engine, so that you have much more efficient way to run this engine. So this is something, of course, later on we also mention why, so that we also have this kind of pressure sensor used in the tire monitoring, TPMS, right? So that something, this is one most mature tire pressure sensor is TPMS is another one later, right? Become much cheaper, so that the TPMS, I think we mentioned about TPMS, right? In here, TPMS pressure sensor for tire, increase the safety. Okay, so that Okay, so that this is something we already discussed at least multiple times. Like 2 days ago. I do hope that you can really understand. Don't I do say, of course, press sensor also is it in your smartphone. But why we press sensor in smartphone? Why? Why we use press sensor in smartphone? Smartphone press sensor is using as sometimes they call barometric press sensor. Okay, what's this kind? Barometric press sensor in smartphone. Okay, so basically this is the sensor try to look at this kind of altitude or something. Now every smartphone will have GPS, right? GPS. Okay, we have a good student. Jing Ho mentioned, yeah, it detects this kind of altitude high, so that then it's quite important. Why? So that so our every smartphone have this kind of GPS, right? Which can provide this kind of coordinate system, right? Provide this kind of X and Y coordinate system, right? Why for navigation? But if you try to go through some kind of a tall building, why and then in this case, the kind of pressure sensor, barometric pressure sensor can provide this kind of altitude. So that in this case, for navigation, so that navigation is quite useful. Okay, navigation is quite useful. Okay, so that of course, one student mentioned touch sensor. There are several ways to make touch sensor for a smartphone. One is capacitive touch sensor, another is pressure, like array or pressure sensor array. So there are several ways to make touch sensing for smartphone. Okay. Okay, so here I just mentioned about this. Now let me go back to the lecture. Typically, we have two types of pressure sensor. Basically, first is we need to have one. We need to have this kind of diaphragm, very flexible micro diaphragm, and then so once it apply some pressure, and then it could cause deformation, and then so that in this case, I mean, so we have pressure apply, right? Pressure apply, and then cause deformation, mechanical deformation, right? And then in this case, deformation. I mean, we can call maybe X trend deformation or the displacement X. Right? And if we try to use maybe two type capacitance sensing, if we have a pair of microelectrode and then a pair of microelectrode become what? Capacitor. So once you change delta X and then we change the kind of capacitance. Why? So in this case, from input pressure to displacement, why? And then we have C. Why? So in this case, we can try from P to C, change of this kind of C capacitance. Then we can make this kind of capacitance. Of course, once you have a change capacitance, and then we can convert it to some, most likely is voltage signal. So all this kind of our CPU or processor, MCU, microcontroller unit can read this kind of, have ADC, read this kind of voltage, right? So that this is a voltage, this thing. And of course, there's another way is we have piezoresistor sensing. That means if you can have silicon to some doping, either N-type doping, impurity or P-type doping, and then in this case, we can change the kind of resistors into the piezo-sensitive sensing. So in this case, we have sensing with P, apply the pressure, and then cause displacement delta X, and then change resistance, right? So that this one with P and change this kind of delta R resistance, then we can measure this is a very basic way. As I show you, we are able to make this kind of pressure sensor, micro pressure sensor. Of course, why we need to make a micro pressure sensor? Because we make it much smaller, much cheaper. So this is also quite interesting. Why? So that of course, in real product in your smartphone, it's not only my pressure sensor design. So of course, this requires you understand sound mechanics. Okay, and then also this kind of thing, piezoelectricity, and then for the real pressure sensor, now it's not only the kind of very thin, this kind of diaphragm. This is on top view, right? Just that I'll say here on previous slide we show you here, right? Once the pressure we call deformation here, right? So that then we have integrate this kind of electronics, analog, this kind of signal conditioning circuit, and even digital circuit, because our this kind of output from sensor, the signal too small. We need amplifier this signal so that most likely we have some amplifier, the very small signal from our sensor in micro sensor, so that we need to have a very good the kind of design about this amplifier circuit on this kind of NIC design. And then also sometimes many of a computer, smartphone, we have digital electronics. So we have convert this kind of analog to digital. So that's why this become quite important, right? So that again, so this kind of pressure sensor has existed for we can say almost 30 years. Maybe I would say it should probably change into 40 years now. Okay, so that and then start from first this kind of integration 1970, but now you see every smartphone have this kind of low cost man pressure sensor. So this is something I tell you it become quite important thing. Yeah. And of course, to make this thing to happen again, it's non-trivial. As I told you, analog IC design require about 4 to 5 years. You need study in the PG. Okay, so that this part is non-trivial. Okay, typically require about 4 to 5 years, minimum 4 to 5 years. You learn about this now to in a PG study, so that you are able to design this kind of NIC. As I mentioned before, right? So that why the ZTE in Shenzhen got US ban. Actually, US government banned this kind of high speed analog IC, so that once you ban ZTE in Shenzhen, cannot buy the chip or this big company collapse. So this is one of very critical these things. So of course, NIC again is non-trivial, so that NIC design, the chip design is non-trivial. So that of course, as I mentioned, that Professor George Yuan, our colleague, actually has a company to work on NIC design with $100 million now for his start company. So that's something it's non-trivial, but it's critical. But if you know how to work on the design and really make a real product, so that this is something, especially at this moment, it's you can easily get this kind of funding from government, from this kind of VC. So that of course, I told you, I have this kind of $30 million to hire postdoctor on main sensor, this kind of NIC design, so that now I'm very busy on hiring a lot of postdoctor. So that this is something is to tell you that this is both government and also this kind of VC, they interesting invest this kind of very good this kind of microchip, right, semiconductor chip, and also micro sensor chip. So this is something is very important. Okay, and another thing is oh, by the way, for this one, I do think all of you may want to look at your smartphone app. I do think you can look at that particular apps to look at how now in smartphone, right? So that I do believe every of you have smartphone, so that you can easily look at this kind of barometric pressure sensor, so that this is something. Let me quickly show you this kind of thing, and so that at least I do think almost every smartphone have this kind of barometric pressure sensor. So it's something becomes so low cost and mature. If you look at your smartphone, and I do think both Android and iPhone iOS system have this kind of a barometric pressure sensor app. So that of course, last time I also mentioned that you can also download sensor kinetics, so you can look at all the sensor in your smartphone. Okay. And another important thing is about mains accelerometer. I think also mentioned in this video I just showed you, right? So that how this kind of micro accelerometer work. Basically it's a meter, right? It's a meter to measure acceleration. Of course, sometimes in those smartphone company, they don't call this micro accelerometer, look what G sensor. If you look at the Apple, right, iPhone, they somehow call the G sensor. Okay, so that if you download this kind of sensor kinetics, then you can really look at how you can get this kind of real data from your smartphone accelerometer. So that's something is important. Here I just briefly mention how this accelerometer work. Basically is very simple. Again, you have a micro mass spring system. You have this is very tiny mass, micro, and you have spring. This is MK, micro mass spring systems. Just like we have interesting simplify here. You have micro mass and spring system. Okay, this is mass and micro, and then once you have it move around your smartphone, and what happen? And then it causes vibration of this kind of micro system, micro mass spring system for vibration and functional time. So if you have good design, so that this vibration can what? Change, called deformation of spring. This is micro spring. Okay, this is this is micro beam, I would say. Micro beam, micro spring. Okay, so once here, and then again you have once you have an input acceleration. Okay, maybe G. That's what G sensor. Right, encodes this displacement of spring displacement. Right, this is originally maybe it's here, and once vibration, and then you can change maybe here. Right, you code this here, and then vibration, a function of time, and then if you can convert this kind of a vibration into what? Electrical signal, and then for example you have a micro there are two micro electron become change capacitance. So in this case, once you G into acceleration to X and to what? C capacitance. While we have two pair of electron, and then once vibration, then we can input acceleration, output capacitance, and then you can do this kind of measurement about this kind of acceleration. So this is very basic thing, can show you how these kind of device works. Do you understand? So without going too much more detail, but at least this very simple way. And of course, in real product, it's non-trivial. In order to have very good design to real product, you can look at this kind of thing. Basically, you have a much more sophisticated folded spring. Oh, this require you have started a lot more mechanics, sound mechanical design, so that this require a much folded spring, and also not only simple one pair electrode, you have a series of micro for capacity sensing to improve performance of this kind of real product. Do you understand? So that this is something I tell you in reality, right? So that previous slide show you very basic concept, but in reality, you need a lot more engineering design, I think, to become good design. And then of course, the same thing to the this kind of pressure sensor, we also need to integrate this kind of analog circuit, right? Amplify very weak signal. For example, design some kind of operation amplifier circuit, right? And turn into the digital signal, right? So that so this is they do have a series of this kind of design in terms of micro machine design and also NIC design. So it's as I told you, it's still non-trivial, but now it's become so common now. Every smartphone or even smartwatch has this kind of motion sensor. Right? In the video I show you, right? They also use the kind of maybe VR, AR, MR. So all this need this kind of MEMS motion sensor. It becomes so important. See, yeah. So you can see now I would say every year. Do you know how many this kind of pressure sensor was fabricate? That's quite important for you to think about how big is the market. How many this kind of MEMS motion sensor was fabricated every year? Do you have an idea? At least billions of this kind of low-cost MEMS sensor was fabricated every year for billing. It's billing. One student chuck one is not 100 million. Billions of this kind of MEMS motion sensor made, okay, every year. So it's every year. It's a quite important business, I say. It's not chuck one. I told you this area keep expanding, so that for those of you want to get rich, this is areas quite of course. If you don't know how to make a pressure sensor, but if you have know how to use kind of a sensor for real application, right? Like our friend Wang use MEMS motion sensor for MEMS motion sensor for drone, of course, especially MEMS IMU. For drone, and then so that also quite important. Consumer drone, right? Just like our DJI, so that this is something. Then so this is something. So anything now, I would say the micro sensor becomes so important not only for smartphone, smartwatch, smart building, or the smart self-driving car. It's one of a quite important technology. Now, things so that of course this kind of sensor is going to expand a lot more, right? Of course, as I show you, this is a very sophisticated design, micro mass spring system, right? And now all the iPhone, smartphone has this 3-axis motion sensor, MEMS accelerometer, and also gyroscope. Gyroscope also quite important. Basically, how the gyroscope work. Traditional gyroscope is very large. It's like spinning this kind of mass system, like in the probably World War II. So that the kind of traditional mechanical gyroscope is quite important for navigation and control for airplanes, but that is being miniaturized. Right? Traditional is a gyroscope, most likely is spinning mass. Okay, mass. This kind of mass spring system. Right? For traditional mechanical gyroscope, okay. But for our smartphones, gyroscope basically is a micro mass spring system. It's basically is also mechanical mass spring system, okay. But it's still micro mass. You have this kind of inertia M and K micro mass spring system, so that once you have a harmonic vibration, and then you have linear. Once you rotate your smartphone, and then you can cause the kind of a Coriolis force, right, and induce additional deformation of microspring, so that once you have this kind of omega angle, rotate your smartphone omega, and then cause this kind of deformation of this kind of X, and then you different into C, right? So omega is angular rotation of smartphone, and then you change it become electric signal. So this is a very basic thing now, how this kind of micro gyro work in your smartphone. Okay, and of course I tell you this kind of real picture about iPhone use ST microelectronics, see, and then also of course, you also have a micromagnetic sensor, as digital complex. This company in Japan, Asahi Kasei, is one of #1 company, make a low-cost magnetic sensor for every smartphone. It's something, basically it's Hall effect sensor, okay? So that measure this magnetic field of the Earth, right? So they have this kind of digital compass, okay? You also have additional app, right, in your smartphone. And of course, DMD will show you in 20 years, almost $1 billion R&D finally become real product. Only one company. That's why several company in mainland China, they are really try to think about how to make their own thing. One student also asked, well, green building including methane, of course. You sent to green building we have discussed at least about more than 1 or 2 weeks ago. Definitely green building we're including in this kind of exam for sure. Yeah, there's no, yeah. And then, okay, so that, of course, most of the kind of, most of what? Segway. So this is something quite important for more thing. And then I think we almost run out of time. So in our today's video, we will show this how it basically is electrostatic. It kind of, once applied voltage, electrostatic force, it can turn this kind of a micromirror, right, in one digital way, so that this is quite useful for computer projector. There's a series of companies in mainland China. They buy DLP or DMD for real product. At least one company in Chengdu, they went to public in, I think, in mainland China stock market. But you see, that's something, if the US government ban this TI to sell this thing, then this company collapse. That's why I have a project, ongoing project, how we can make micromirror. See, in case the US ban this kind of US chip, then so that I do think it's quite important to make our own. Of course, DLP chip can also use to make TV and also VR, AR. So this is quite important. And see, I think we run out of time. So again, do you have any question for today's lectures? Today's lecture, for those one we have discussed, well, but we will not cover today's lecture, but there's an overlap, right, by basic concept of a micro sensor. So it's covered, we discussed in previous lecture will be covered, okay? Okay, so that, anyway, so that will not give you those kind of new content today, but all I would, at least all of you have learned about this DMD, right, last time. So we cover in our midterm exam. Okay, any additional question, please feel free to ask question on our Canvas discussion thing, so that please, I think we have very not too many students ask question.